Right, this third exercise is focused on the piecewise function. As you can see here, we have the function is 1 in this interval and t for t greater than 2. Okay, so in this case, we have to break the formula into two parts. So it won't be the integral from 0 to infinity as we used to do. In this case, we have to take the first integral from 0 to 2 and the second integral from 2 to infinity. Let's do that. By definition, the Laplace transform of the function f of t is the integral, first part from 0 to 2 e to the power minus st times 1, okay, this one, dt, plus the integral from 2 to infinity of e to the power minus st times t dt. All right, this makes sense, I guess. So the first part is straightforward. This integral is minus 1 over s e to the power minus st from 0 to 2, right? And for the second part, we have to do the integration by part. So for the integration by part, we have let f be t and g prime is equal e to the power minus st. Then the derivative f prime is 1 and g, the antiderivative, is minus 1 over s e to the power minus st. All right, if we apply it here, we have this first two, this is minus 1 over s times t e to the power minus st. We are taking from 2 to infinity. Negative sign times negative is positive, so plus 1 over s, the integral from 2 to infinity of e to the power minus st dt. All right, here this integral, if we set when t become 2, then we have e to the power minus 2s, and when t is 0 is e to the power 0, and that's 1. So this becomes minus 1 over s, first limit, minus 2s minus 1. For the second part is minus 1 over s. So at infinity, this is 0. And at 2, this is minus 2 times e to the power minus 2s. For the last part, it is 1 over s. The antiderivative of e to the power minus st is minus 1 over s times e to the power minus st. The integral goes from 2 to infinity. Okay, so let's continue here. This is, for the first one, minus 1 over s times e to the power minus 2s plus 1 over s. For this second part, this is 2 over s times e to the power minus 2s. And for the last one, 1 over s bracket minus 1 over s, 0 at infinity, e to the power minus infinity is 0, and this is e to the power minus 2s. Right, we expand this. This is 1 over s. We start with 1 over s. This and this is just plus 1 over s times e to the power minus 2s. And the last part, the negative sign multiply this, it become positive. So this is 1 over s squared times e to the power minus 2s. Okay. Finally, we have 1 over s plus 1 over s plus 1 over s squared. All this multiplied by e to the power minus 2s. So with the step function, it's also straightforward. You just make sure that you respect the boundary. So the integral is not from 0 to infinity, but it's follow the boundary. In some examples, you may have three-step functions here. So you have maybe one from this to this, and you have another one from maybe 2 to 10 or to 5. And the last one maybe when t is greater than 5. So those are the examples that you can have, and you should be able to solve following the same structure, okay? That's all. Thank you so much.